These are Chapter 3, Section 5, Problems 17 through 27. So we have the logic statement that all birds fly. That's premise 1. All planes fly. Therefore, a bird is not a plane. And I think your initial reaction is that doesn't make a whole lot of sense, but let's prove it using Euler diagrams. So what we have is we have the big circle, and so things that fly. That's the outside circle. All birds are the inside thing. So we can put the circle in here. So birds. So birds are one of the things that can fly, and all birds can fly. Now the second premise is all planes fly. So what that allows us to do is it allows us to stick that also in here, but it doesn't allow it to be inside the other circle. So this is planes. So of things that fly, all of the planes fly. Now the conclusion is a bird is not a plane. So you might say, well, yeah, if I here's a bird and it's not a plane. But the problem is that they could be overlapped like that, and therefore a bird could be a plane. So there's nothing that says they're separated or whether they are intersecting. It just tells us that these two are within the large circle. So this is an invalid argument because I can't make this inside of this, which makes it inside of that. That's kind of the usual case. You might have, what you would have is, let's say, all birds fly, which actually is not true, but let's say it is. And so let's say this is a wren. So what would be a valid argument is that all birds fly. A wren is a kind of bird, or all wrens are birds. So then you could say that all wrens fly. That would be the wrens fly, would be the logical argument using these same examples. Okay, the next one is all cars have tires. The next one is all tires are rubber. And the next one is all cars have rubber. Okay, so these are the two premises. That's the conclusion. So we'll take the two premises. We'll draw a circle to represent things that have tires. Because the thing that the all refers to is always the thing that's inside of the other thing. So all cars. So here's cars. So all cars have tires. There are other things that have tires. You could have trucks. All trucks have tires. Then all tires are rubber. Okay, so then what you have is you'd have things that are, so in this case, what happens is that you have, so it's a little bit different than what we have so far. What you would have is this bigger circle like that. Things that have tires, or tires, you could even think of tires and cars, and this is things made with rubber. Okay, so tires can be made of rubber. other things can be made of rubber. Then all cars have tires. So because the car thing is in the middle, that's the all part, all cars have rubber. So since this circle is in with the big circle, then that is a valid argument. So that's kind of a different one we did before. We put a little cross in here and we didn't have this extra ring, but the key thing is that this is inside of that, which is inside of that. Okay, number 20, all chickens have beaks. Looks familiar. So all chickens have beaks, all hens are chickens. That's similar to what we did, but all hens are chickens. All chickens are birds. Oh, I get what's going on here. So these all involve all. The first couple had some statements, all. The first statement was all, the second statement was not all. And then we had some conclusions. So these are different in that they involve things inside circles, inside of circles, inside of circles. So it kind of goes along with example 4 in the book. Okay, so I don't know why I didn't think about that earlier. Makes me think I never did these problems before. Okay, okay, so let's do this. First one is all chickens have beaks. So we have things that have beaks with beaks. So chickens, all kinds of birds, that's kind of things that have beaks. So now inside here, so the first one is all chickens have beaks. So this is chickens. So that's one thing that has beaks. You could have other kinds of birds. Okay, so that's the first premise. The second one is all birds have beaks. So if I did all birds have beaks, then what that does is it puts that in here somewhere. Now a chicken is a bird, so except we don't know that chicken is a bird. I mean, we know that, but yeah, so you have to answer these questions relative to what's stated, not but what you understand. So the only thing, the second part that says all birds have beaks, is that if this is the circle for birds, let me write down that birds. Let's group those together, the title. So all I can say is it's inside this circle. It may be like that. Chickens may be birds, but it doesn't say that. So it doesn't restrict where I put this in there. So as a consequence, this is not inside of that. So our conclusion, all chickens are birds, the only way that would happen is if this were true, that this bird circle was outside of the chicken circle. But since that's not forced on us by this argument. And I just realized I wrote 20 down, but this is 19. Okay, so 20 is all birds have beaks. You probably already know this. I mean, all chickens have beaks. And all birds have beaks. This is also a example of where an argument can be true, a result can be true, but it's not a valid argument. Okay, so let's, even though this was not assigned for your homework, let's do this one. So, so what we can say is all chickens have beaks. So again, we could draw a bird inside here. So things, this is things that have beaks. This is chickens. Then all hens are chickens. So the all part goes inside the second thing. So this is hens. So we have hens and we have roosters. So this is hens. And because this is inside of that, it's also inside of that. So, and I wrote this down. This is kind of a mishmash of the two. I think I just looked for the wrong thing, but let's do this one right. So all hens have beaks. So this is number 19. All chickens have beaks. All hens are chickens. All hens have beaks. So by doing these two, chickens are inside of beaks and hens are inside of chickens, then hens is inside of beaks, and therefore this is a valid argument here. And this one is invalid. Okay, the final one is 27. So that says all people who drive contribute to air pollution. All people who contribute to air pollution make life a little worse. Some people who live in the suburb make life a little worse. So whether you're using this as an example where you have one of those sum words. So let's just see what we can get out of this. So all people who drive. So we need a circle inside of a circle. All people who drive. So all people who drive. So this is people who drive. People who drive contribute to air pollution. Things contributing to air pollution. Okay, all people who drive are contributing to air pollution. The next one is all people who contribute to air pollution make life a little worse. Okay, so that one's that's a difficult one to do, because you think about it, all people who contribute to air pollution. So these are people who drive, but there are other people that don't drive, but they still contribute to air pollution. So what you would say is these are people, just people in general. Actually, what we'd have to do is so here's people in general. And it would go like that. So this is people who drive. This is just people. So people who drive are a subset of just people in general. Some of those people drive and contribute to air pollution. Some of those people who drive, people who don't drive still contribute to air pollution. Some of those people who don't contribute to air pollution at all. Okay, and then the next one is all people who contribute to air pollution make life worse. So what we would do is that one would be, let's see, it would include people who drive. It would include people who contribute to air pollution. And what we're trying to do? All people who contribute to air pollution make life a little worse. Okay, so let's see how we draw that one. So that one actually would go something like that, I think. That would be, makes life a little worse. So what it says is all people who contribute to air pollution. So these are the people. It would actually be this kind of weird shaped thing. So it's people. It's in the people thing, but it's also in the things that contribute to air pollution. And then that's in the bigger circle, things that make life a little worse. And then the final one is some people who live in the suburb make life a little worse. So you'd have to have another one, which would be inside people, but people who live in the suburb. So that would be not everybody who lives in the suburb drives. Theoretically, most of them do. So people who drive, this has to be in people, but includes some of the people who drive, but some people that don't drive. And so, the bottom line is anything you try to make out of the conclusions out of these three statements are invalid, except the last case, which is problem 30. All people who drive make life a little worse. And anyway, the point is, what I want to get at is that just because something says all doesn't mean that there is a way to use Euler diagrams to prove that they are correct or they're valid.